Welcome to the class of Advanced Maths in the class 8. Now today I will discuss the chapter Laws of Indices. Before discussing the chapter Laws of Indices, we will discuss about power and root. What is called power and what is called root. If we discuss the power, then we know very well if we write 2 cube. What do you mean 2 cube? 2 cube means 2 into 2. There is a continued product of 2. Or if we write 2 to the power 5. What do you mean 2 to the power 5? 2 to the power 5 means 2 into 2 into 2 into 2 into 2. There is the continued product of 2. That's why we say this 2 to the power 3 or 2 to the power 5 is called the third power of 2 or fifth power of 2. That means 2 to the power 3 is called the third power of 2. Same as 2 to the power 5. If we say 2 to the power 5, then 2 to the power 5 is also called the fifth power of 2. That's why if we suppose that a to the power m, then a to the power m means the continued product of a up to m factors, to m factors. That is, we write m times. We write a m times. There is a continued product of a up to m times is called a to the power m. Then m is what? M is the power of a, and a is what? A is the base of the things. Then this m is also called exponent or index. This m, the power m, is also called exponent or index. So if we suppose that x to the power m equal to a, then this is m is the mth power of x, and also this x here it is x to the power m equal to a, means what? This a is called the mth power of x, and hence we may write it is x is equal to a to the power 1 by m, or it is mth root. This is also called mth root of a. Here if we suppose that x to the power m equal to a, then we write this x is called the mth root of a. This is called mth root of a, or a to the power 1 by m. So as we suppose that if it is, you write x square is equal to a, that is this m equal to a 2, then we say that x square equal to a. That means what? This x is called the square root of a. Here we write the square root in this way. Again, if we suppose x cube is equal to a, then this x cube is equal to a. For that we say this x is equal to cube root of a. This is cube root. We write the cube root in this way, cube root of a. Here this a, square root of a, is write as a to the power half. This cube root of a is written as a to the power 1 by 3. As well as if we suppose x to the power 4 equal to a, then we say that x is equal to a fourth root of a, or it is a to the power 1 by 4, and so on. So these are the relationship between power and root. Here x square means this is the second power of x. Second power of x is equal to a. In the reverse way, this x is called the square root of a. Similarly, if there is 3, x cube equal to a. If the power is 3, then this is called the third power of x. This third power of x is equal to a. Then in reverse way, this x is called the cube root of a. So it is power and it is root. So it is called cube root of a to the power 1 by 3. So this is the basic relationship between power and root. Before going to the chapter laws of indices, we will just discuss what is called power and what is called root. Now we write some formula of laws of indices. We write some formula of laws of indices. These are very important. What is the formulas or laws of indices? Some laws of indices. Again, we write here. So here, if suppose m and n be two positive integers. We suppose that the two numbers m and n are two positive integers. Then the first law is a to the power m into a to the power n. What do you mean? This is mth power of a. This is mth power of a. This is nth power of a. If we multiply these two, then the result becomes a to the power m plus n. The power will be added to both. What do you mean by a to the power n? There is a continued product of a up to n factors. What do you mean by a to the power n? There is a continued product of a up to n factors. Then if we multiply both, we get a to the power n plus n. As for example, if we say example here, suppose it is a to the power 2 into a to the power 5. What do you mean by a to the power 2? There is a continued product of a in 2 times. So we write here a into a, the continued product of a up to 2 times, and here it is a to the power 5. What do you mean a to the power 5? There is a continued product of a up to 5 times. This is a up to 5 times. Then all the terms are multiplied to each other. Therefore, there is a continued product of a up to 7 terms. Here it is, if we write a into a from there, and again if we write a into a into a into a into a, that is, there is the product of a into 7 terms. Then what happens? We write this a to the power 7. Then what we get? A to the power 2 into a to the power 5 equal to the power 7. This means that is a to the power 2 into a to the power 5 equal to a to the power 2 plus 5 equal to a to the power 7. So this is called the first rule or first law of the indices. So please remember this law, that is a to the power m into a to the power n equal to a to the power m plus n. And this is the example. Again, the second law, just to rough it, the second law is what? The second law, that is, the second law is like that: a to the power m divided by a to the power n. A to the power n divided by, there is a multiplication, there is a division. So if we divide them, or we can write this is like that: a to the power n divided by a to the power n. We may write both the same. We may write in divide symbol, or we may write in this way. Then the power will be subtracted. The laws indicate the power will be subtracted. A to the power m divided by a to the power n, then the power is subtracted, a to the power m minus n. This is second law, and as well as we can explain it with some examples. If we suppose that a to the power 5 is there, and then a to the power 2 is there, then we can write this a to the power 5 minus 2. The power will be subtracted like that, and it is a to the power 3. 5 minus 2 equal to 3. So power is important. So discussing the laws of indices, this power and base, the relationship, the base are same, and then powers are different. Then this is the power base, and the power will be subtracted, and then the law is the second law, that is a to the power n divided by a to the power n equal to a to the power m minus n. The third law is a to the power m to the power n. This is also important. A power m, then again it is power n, then there are m into n, there is m into n, then these two powers will be multiplied to each other, m into n. Suppose if we write that a square to the power 3, here is power 3, it is the example, a square power 3, for this power 3, this square is multiplied repeatedly up to 3 times, a square into a square into a square. Since for this power 3, this square is multiplied 3 times by the definition of continued multiplied of a square up to 3 times, then a square into a square into a square. After that, these are the base are same in all that 3 terms, so bases are same, the power will be added. This power 2 plus 2 plus 2 will be added. Then what happens? The power is added. If it is added, then 2 plus 2 plus 2 is equal to 6. So a to the power 6 is there. How it is a to the power 6? If it is a square to the power 3, then this two terms 2 and 3 will be multiplied to each other. 2 into 3 equal to 6. So it is a to the power 6. In this way we can explain the third law. The third law is also very important. A to the power m to the power n equal to a to the power m into n. Okay. Then what is the fourth rule or fourth law? The fourth law is that suppose if we write in this way, the multiplication of two numbers a to b, the power is m. ab to the power m. ab to the power m means what? This ab factor, this ab base is multiplied m times. Is a continued product of ab to m factors. Then we can say it is a to the power m into b to the power m. A into b whole to the power m is equal to a to the power m into b to the power m. This is the fourth law of indices. So a b to the power m equal to a to the power m into b to the power m. This is the fourth law of indices. We will discuss this. We may take example of this. A into b to the power m equal to a to the power m to the power m. Then fifth law. What is fifth law? Suppose a to the power 0. A to the power 0 is always equal to 1. We say anything to the power 0. 0 means what? This term a is multiplied continued product of no terms. No? Since there is 0, so a what is the definition of power of power? There is a power means it is multiplied of that times. So there is 0, so a is multiplied of 0 times, and since a is multiplied of 0 times, then it is equal to 1. A to the power 0 equal to 1. Then the sixth law, it is a to the power 1 equal to 1. Sorry, a to the power 1 equal to a. A to the power 1. Anything to the power 1, if it is the power 1, then it is equal to a. Or if it is a, then the power should be equal to 1 always. And the last is what? A to the power m. If it is a to the power m, then you can write this 1 by a to the power minus m. 1 by a to the power minus m. If it is a to the power m, for any necessity, for any solving the problems of necessity, then a to the power m, then the right is 1 by a to the power minus m. Or here it is a to the power minus m, then for necessity of the problem, solving the problems, we can write this 1 by a to the power m. So if for a to the power minus m, if the power is negative, then it is reciprocal 1 by a to the power m. If the power is positive, for necessity of the problems, we may write this 1 by a to the power minus m. So this is the laws of indices. Please stop.